Hey everyone, welcome to the Tom's Hardware Podcast for today, June 27th, 2023. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, friend of the show, Phil Howard of who does all the dev work for Pimoroni, otherwise known as Gadgetoid. And he's here to talk to us today about some of the really cool things that they are working on. And we're all very excited, of course, to talk about where things stand with Bluetooth on the Raspberry Pi Pico W.
Oh, yeah.
Because everybody was real excited a few weeks ago when it sort of became official that you could do Bluetooth and MicroPython, but the libraries have been kind of difficult to work with or very not abstracted enough, as Les says. So I know you're working on some stuff for Pimoroni's, I guess could we call it a flavor of MicroPython? You guys include, have your own sort of image, which has all of your cool libraries built into it.
Batteries included MicroPython, I think, is the phrase.
So how is that going, and what's the latest?
So I think I have now released a firmware that supports Bluetooth, but we haven't got, as you say, the abstraction layer over the top of it yet. And that's something I've been looking at over the past, since Bluetooth launched, is to try and come up with a canonical demo that would make some of our products do something with Bluetooth. And the obvious focus was Enviro, because they're environmental sensors. Bluetooth Low Energy has an environmental sensing. What's the phrase for it? I wrote this stuff down. No, I can't read it back. Basically, it has an environmental sensing profile you can use, and then you can have any number of specific sensors within that. So I brought up one of the MicroPython demos on an Enviro indoor, which is stuck up on my wall somewhere over there. And via the magic of Bluetooth, managed to get it showing real-time statistics to a Pico W connected to a Pico display.
Nice.
The great thing, apart from having to surmount the complexity of Bluetooth with the Bluetooth stuff, is that you fire up they call it, what's the word? Central devices are your hosts, your kind of clients, I guess.
Right.
And your peripheral devices are, for example, your sensors or your beacons or whatever that run something small and do a very lightweight task. So the individual Enviro boards will be peripheral devices, and they will broadcast and say, "Hi, I'm here, connect to me." And the idea is to have some code that you throw onto any device with a screen, and it goes and finds all the sensors that are saying, "Hi, I'm here," connects to them, figures out what data they've got, and just figures out how to display it nicely on screen. So it's kind of like just plug everything into power and it goes kind of setup, which is starkly different to our current Enviro firmware, which is sort of gives you an onboarding process where you put in your Wi-Fi details and you put in where you want the data to be uploaded. This is all kind of in-home. And if you want the data uploaded to the internet, you run a Pi that connects to the Bluetooth devices and acts as kind of a Wi-Fi internet connection for them.
That makes a lot of sense. So one thing that we've seen, I think, with Bluetooth on CircuitPython is that there's some issues with having pairing be maintained across sessions. Is that something that the new Bluetooth libraries solve or will be able to solve, or do you have to kind of
run into it at all? Because I haven't touched in MicroPython upon the more conventional Bluetooth where you would actually do a pairing session to connect to a controller or something like that. With Bluetooth LE, you don't have pairing in the traditional sense. So every time you restart, your firmware will go out and it will find the sensors in the room and it will connect to them again, and it will happen pretty fast as well. I think if I go up and reset this board back to 0, I'll get an idea of how quickly. I can't reset it without unplugging it, can I? No reset button. Sorry, little Lego man. Get a sense of how fast this comes back online. If I can get the port in blind. So there we go. We'll have the metrics, and then we'll get our first broadcast. So that was a couple of seconds at most where you're re-establishing a connection. And the The device side is pretty bulletproof. It just runs all day forever, and you can disconnect and connect to it as you see fit. And it's simple enough that you don't necessarily have any problems with it crashing or getting into a bad state, because all it's doing is broadcasting, throwing these readings out into the ether. With the more traditional Bluetooth stuff, I haven't touched upon pairing, but we do have what did I call it again? The Galactic Unicorn Bluetooth firmware with the VU meter and stuff. One of the things that's coming to the underlying Bluetooth library is album art display. So if you connect your phone to a Galactic Unicorn, for example, or anything with display, you can send album art, or it automatically sends album art over Bluetooth, and then you can display it on whatever device you've got.
Cool.
Running your audio at your speaker.
So Kevin asks, Kevin asks, is Bluetooth is all this work in MicroPython, or is it C only right now?
All of this stuff that I've just demoed is MicroPython. The code all uses the AIO BLE library, which is an async IO Bluetooth library, which obviously you have to surmount working with async code, which is something that I've managed to avoid for my entire career. So getting my head around that is one thing. And then you've got to surmount the Bluetooth documentation, which, and I'm going to quote Raspberry Pi here from their docs. It says, the Bluetooth LE specification is a sprawling mess of interlocking documents that run to thousands of pages. The core standards document is over 2,700 pages just on its own. Proceed with caution.
Yeah,
Great.
It's a myriad of just like maze-like documentation. When I was looking at the original release firmware about 2 weeks ago now, it just was like 500 lines of code to get two Picos talking to each other. It's like, that's great, but can we abstract that into something where I can put this in front of a 10-year-old kid and say, make that, talk to that, here's the basics.
Want effectively the microbit approach, where you just have a very, very simple, I'm sending data, I'm receiving data. And that's easy to implement over the top of BLE. I have in my notes, you could ignore all the specification documents. They don't matter. They are only relevant to interfacing with devices that implement the standards. If you've got two Picos and you want them to talk to each other, you can go, no standards for me, please. And you can just make them talk however it happens to be convenient. And that can just be sending individual characters over BLE or connecting some UART or something to that effect.
Yeah, that's something that we need, because right now, if you look at it, it's just too difficult. I mean, I'm not a novice at coding. I'm not an expert in coding by any means. But even I was looking at documentation going, what is this doing? I'm just copying and pasting and hoping for the best.
When I was doing the bring up for the client, the display side that had to connect to the sensors, I basically ran it. After a few minutes, it would crash with a new error. And I went, okay, I'll catch that error and handle it and reconnect and do whatever. Then run it again. A few minutes later, it would crash with a new error, catch that error, roll with it. And I went through this process about 5 times, trapping all these various different errors that happen just because there's a timeout somewhere in the underlying protocol that happens at different points in the code. So it throws different errors depending on how broken it is at that specific time. So yeah, just things like that, trying to abstract away as I kind of slowly work on this Enviro BLE firmware that I'm putting together. One of the first things I abstracted was just sensor readings, but that's extraordinarily specific to Enviro, so it's not super useful for someone who wants to do it for other reasons. But I think you're very right that there needs to be a library out there that sweeps this complexity under the rug, because it is difficult even for me, I think.
Bluetooth 0.
Well, yeah, exactly.
If there's no pairing, how do you make sure that the one Bluetooth device works with the other Bluetooth device without it being paired, like connecting to a different one that you didn't intend?
You can implement that how you see fit. In my case, I'm just going by the name of the device. So when I put the Enviro BLE firmware onto an Enviro board, it will detect which kind of Enviro board it's on, and the name it broadcasts will be Enviro and then the type of board that it's on. But it can also broadcast the serial number of the Pico W, so you can verify the serial number against your database and figure out, oh, that's the one that I connected to before. There's no security on it whatsoever, so if your neighbor happens to also enjoy tinkering with pies, and is within suitable range, they can just connect to your sensors and go, "Ha, it's mine now."
That's one cool neighbor.
Yeah, to be fair, I don't think any of my neighbors are up for that, but you just never know.
The range isn't super great, so it's not that the sort of thing that's going to be a huge problem. But you could probably go war driving connecting to Pico W sensors at some point.
But maybe you could use that to your advantage and have communication between multiple devices, so that you have different readouts in different locations from one source.
So if I want to connect something like this little Bluetooth controller here, this 8-bit do controller, like how would which is Bluetooth? Is there any way to do that with a Pico W, to connect this to a Pico W, or is that
You're talking about in MicroPython generally? At the moment,
Yes.
I don't know. I have one of those on my desk ready for me to get around to trying it.
Cool. I mean,
that will be because it's such a small controller and it's great for this kind of thing and for working right. That'll be probably the one that I will get working and do an example for, and maybe make it do something interesting on Galactic or Cosmic.
Well, I have a very specific use case, which is that my son and I have our Galactic Unicorn game, and what we found was that we didn't have a great controller for it. Either we were controlling it through a web browser, which is painful and makes the whole thing slow, or using the buttons on the Galactic Unicorn, which are not a great controller. So, like having either a wireless or a wired way of controlling it with a controller seems like would be a cool thing to do. The other ambition that we have is to actually make our own controller that we could possibly interface with a Nintendo Switch or a PlayStation, and use the Bluetooth on it to make it like a DIY game controller.
Thought you were going to go TAS then, the tool assisted speedrun style things where the game controller just plays the game for you.
I mean, that could be interesting too, but I wonder. We've looked at, I remember looking at this on the Arduino. What was it? The Arduino RP2040 that had technically you could do Bluetooth on that, but getting it to actually have to stay connected or whatever to over time, like a console would kind of demand that you do.
Yeah.
It seems to be a challenge because it doesn't do you can't do pairing, at least as far as we can tell.
Does mean I'm going to need to get a games console so I can test this. Better expense that.
That actually would be like a cool project. That would be a cool project for Pimoroni to make. You guys have made like a keybow that you build your own keyboard and things like that. It would be kind of cool if you could have make your own game controller kit where you had the pieces and you could put it together. But I'd like to try that myself with a 3D printer and take it.
I think if we ever manage to put together a wireless Pico system, that would effectively be good to go.
Yeah, that would be cool.
I don't need the screen, just connect it straight to the control.
Yeah, but anyway, I mean, I think it's something that would be really cool to do but it's great that we now have the ability to do Bluetooth at all, because when Pico W came out, obviously it was built into the hardware, but you didn't have the ability to do it. So
people were itching for it.
It's great that you're on the front line doing this work, and the stuff you do is so amazing. We're reading that code, my son and I working on projects, we're reading that code every day. So it's very helpful. What are some of the other things you're working on right now at Pimoroni to improve the experience?
To improve the experience, that's a very good question.
Or hinder it.
Or hinder it.
Yeah.
We're certainly making more products, which means there needs to be more software. One particularly recent change has been to Picographics, which is the drawing library behind all of our display products, like these things here that I can't reasonably point to. I finally added support for custom fonts and spent a not insignificant amount of time going, I like to edit fonts, but I don't like using Photoshop to edit fonts. So I'm going to write my own font editing tool. And then I spent a very large time wrestling with Tinctor, or whatever it's called, the
What a
TK
detour.
library for graphics, and came up with like a little pixel font editing tool that would support specifically our weird binary font format. So you can then point MicroPython to a binary file and say, load this as a font, and voila, you get a custom bitmap font. So that's
Fun.
actually launched in our latest release, and people are already tinkering with their own font customization and tweaks, which is nice. I think
so cool.
it's always someone either wants a bigger font for a bigger display, and we have some bigger displays on the way, kind of theoretically, or a smaller font for a smaller display. So it sort of makes sense.
That is good time saving. I had to do that one like block by block, and the code is not pretty.
Yeah, I've been there, done that, and it gets scary pretty fast.
Yeah.
Yeah, but you're like Galactic, like the Galactic Paint program that you include is really, really helpful. So I of course have modified it to turn to a level editor for the game that I'm working on, so I can draw like the layout of the level and make it go longer than the length of the display, so you can like have it scroll. But that is like that's been really, really awesome. Just the work that you've done on Picographics. Like there's nothing like it out there natively for MicroPython or CircuitPython.
I think MicroPython are very slowly getting there because they've got their own surface library that handles drawing pixels in different types, but it's slowly getting the various different primitives and stuff that will make it into a useful drawing library at some point. I think it's already useful. I'm not damning it with faint praise, but
Pimoroni is setting a standard, though. It is good.
Cool. So what are some of the? So I see that you were doing something with Numpy recently to actually create a graph on the cosmic unicorn. What is that like?
Done these two with Numpy, which is really handy. It's just an incredibly good way to move pixels, is Numpy. Like the trouble is you have to kind of think tangentially about how things will work. Normally when you move pixels around, you go, I just redraw the frame every frame, whatever. That's how you would create an animation. You just do it frame by frame, change every pixel, or try and optimize things by changing only the pixels you actually need to change. Whereas these are basically sticking the flag design. I really can't point today. These are sticking the flag design straight into a NumPy array, and then just using a sine wave to roll each column of it into another array that then gets flipped to the display. So it means you don't actually update the full graphics buffer or have to do complex drawing operations every time you update the display. So this one down here runs at something like 140 frames per second. And this one, for some reason, only runs at about 50. But they're still fast for a lot of pixel shifting, which tends to be a complex problem otherwise. But also this is coming soon. This is baby this.
It's adorable.
Very good. It's a clever idea to use a NumPy array. It's not something I thought about. My literal thought for doing stuff with screens was redraw the entire screen every time, and that works for slow moving stuff. You're just doing between like two images, say, great. But for something as fast as that, it's awful.
With
so doing it with NumPy array is brilliant.
Fire demos, we had a regular fire demo that just redrew and kept an array of the state of the fire. And it's kind of a cellular automa in a sense. It generates new fire particles and then propagates them upwards, which is straightforward, but then you have to redraw all the fire every frame by copying that data to the screen. Whereas the NumPy version could take the fire particles and then it could create 5 copies of the array and roll them up, down, left, right, splat them against each other and divide them by 5 or whatever. And that created the same propagation effect. But because NumPy moves all of that code into C, it happens about 10 times faster, I think. So we had the non-NumPy demo showing fire, which was about 10, 15 frames per second, and then the NumPy demo, which was 150 or something to that effect. So if you can wrap your head around the logical shift between drawing individual pixels and maths effectively across a 2D array, then you can really take advantage of like the performance enhancements. And it worked well for Game of Life as well, which I think I had showing in the background on the last podcast, if I remember. Well, the last one I was on, anyway.
I believe
really
so, yeah.
cool.
Conway's Game of Life, yeah.
Yeah, it's just a very ruthlessly efficient way to do it, but hard to reason about, I think.
Very cool.
I was gonna say, yeah, I took your advice and I used that with my game. It was now sort of, and it increased the speed dramatically. It worked a lot better.
I think you were doing exactly that problem space. You were trying to roll your level across the screen, which feels intrinsically like it should be a simple problem. And we've been tricked into thinking it's a simple problem because classic consoles would have just had a register you'd set and that would roll the screen for you. And all you'd have to do is redraw in the last line. So they would have a hardware fix for that problem, whereas we on the Pico don't have the ability to necessarily roll in hardware because there's no hardware frame buffer, there's no hardware GPU.
Yeah,
Kind of reminds me of some of the devs for Crash Bandicoot, the original, talking about how they had to get creative with the way they were generating their levels because they were these huge 3D, environments that you would move through. But pretty much as soon as you would go through part of the screen, it would stop rendering it and it would generate the next little chunk. So it was just generating new chunks as you went along instead of actually moving you through an entire pre-designed level.
I still remember first playing that game and just being wowed at the graphics. It was
yeah. I mean, they had to get really creative, and it was because of the hardware restraints.
Yeah.
That's the trouble with Pico. You don't necessarily have the same set of restraints and the same set of things, so you kind of have to work around them a little bit. And while we're on the topic of hardware, I might as well
that's pretty.
Give everyone a little glance at this. So this is Pico W on one side, RP2040 on the other, and an HDMI port. So when I was alluding to things, this is what we talked about before. I can't remember when now, but that's
the set-top box, right?
It became a games console in the article, I think, which you can do. I think they've got a little split cable somewhere that allows you to plug a controller into it, a USB controller, which is quite silly, but it does.
What is the main reason for that board? What is it, raising?
The main reason is to throw pixels at an HDMI display. It's pretty much the MO. So you get a Pico W to yourself for your application code, and then an RP2040 completely dedicated to pushing pixels out to the display. And it's up and running in MicroPython. So this might be the first Pico W based MicroPython powered board that can use an HDMI display as its output, which is extraordinarily fun and kind of opens up, because it uses Picographics, which is relatively straightforward. It opens up the ability to use a honking great big display for your Pico W projects for whatever nefarious reasons you might have. You could use it to grab data from BLE and display it on a little HDMI dashboard. Unfortunately, the resolution doesn't go super, super high because it's a Pico after all, but you can do some less limiting things with it when you've got a display that goes to like 800 by 600 or 720p a push, I think, in some cases.
Does it have a name?
We're going to call it Pico Vision.
Pico Vision.
And every time I say it, I cannot stop myself going, Pico Vision, Pico Vision. Some
to me.
There we go. Knew you at least would.
Yeah. If anyone who's not British, we're talking about the Chuckle Brothers, who were a kids' TV show for Chucklevision in the 1980s and 90s in the UK. They were massive. They were gods.
The things that were massive on British television, good grief. Oh dear. We're a funny lot.
I'm looking forward to that set-top box. I've been looking at Adafruit's version, the Pico DVI, I think it is, which is it's a stripped back version of that. It only has one RP2040 on it. Oh dear. It's interesting to generate graphics on a big screen with a microcontroller, because we're so used to just saying, oh, we'll use a Pi and just chuck a Pi in and play a load of JPEGs and GIFs and videos and that, and away we go. But now we've got really cheap hardware that uses next to nothing power-wise that you can stick anywhere, and it's it's a commodity basically. Just chuck it somewhere and away you go. So you can have digital signage, easy peasy.
This is true. I think the other side of it is it feels in a very small sense like you're working with a classic console or a classic system, because the graphics are just a little bit fuzzy. They're not glorious, crisp 4K like you would normally expect from HDMI. And being able to program it in Python means it kind of feels like harking back to plugging your Commodore 64 into the TV and programming BASIC a little bit. So one of the things I'd love to do is somehow get a keyboard working with it and some kind of on-screen REPL and editor, so you can just sit there and program graphics on your TV with a microcontroller for no other reason than it will be interesting and cool.
That would be awesome, because there are alternatives in the community. There's the Phoenix range of computers, Phoenix 256, I think it is, and the Phoenix Junior. These are modern computers based on 6502 CPUs, so really old CPUs, and it drops you into a basic prompt and away you go. The problem is, and I love the hardware, I love the kit, $600. That's I can't go out and just say I'm going to buy that.
You can still buy a Commodore 64 for that.
I've got one in a drawer down here.
Exactly.
And that was £100. That's it's cheap. But to get immediate access, just sitting there with a basic interpreter and just typing your code and away you go, or something like MicroPython, something that's abstracted, so you can just say, draw this on screen, do this, move this. It would be fantastic for kids and old men like me to sit there and reminisce about being a kid again.
That is basically the goal, isn't it? To recreate the childhood, poking and pushing, and getting your mum to type in pages of Commodore 64 cheat codes.
I still miss having Compute Magazine, where you would have to type in the whole basic game, and if there was one typo, you're in big trouble.
Yeah, early trackers had that, where they'd release a tracker and it would just be 20 pages of basic, or 20 pages of just hex code that you'd have to type in.
Yeah. I can remember typing in code to make a gunshot sound on a Commodore 16. It was awful, and it took 200 lines of basic.
Grief.
Yeah.
But it was cool and worthwhile. How else were you going to get it?
When you were 6 or 7 years old, that was it.
Yeah.
That was great.
I love it.
Very, very cool. So, speaking of cool things, Ash, you've been looking at some really interesting Pico projects.
Yeah, since our guest today was going to talk to us today about the Pico W, I know that everyone's really excited about Bluetooth, but we don't have a lot of Bluetooth projects yet to share. So I thought I'd share some cool Pico W projects and tutorials and stuff that can get you inspired, and maybe these can be reworked to use Bluetooth instead. So let me get my screen fixed here. Recently, we covered this Raspberry Pi Pico, they call it a Pico W copter. It's a little tiny drone, and it runs a Pico, and you could definitely implement Bluetooth on that. What do you think, Isaac? You could use Bluetooth to maybe make it interact with a landing port or something like that. I'm not sure.
Yeah. Oh, definitely. Yeah.
It's a cute little quadcopter. It's 3D printed, and I think you can control it with he's using a smartphone and has a web interface to operate the controls.
A Wi-Fi drone.
Yeah. But that reminds me of this next thing I wanted to share. Les made a guide on how to make a Raspberry Pi Pico W web server. So if you've never done that before, go over to Tom's Hardware. We have a guide walking you through how to set that up. Thank you, Les. Beautiful work, as always.
Thank you.
Yes. And then we even have a guide, or not, I don't know if you want to call it a guide. We have a list of Raspberry Pi Pico W projects. And this is when it was still pretty new. So there's been, of course, more since then. And we probably need to update it. But there's a network scanner, a garage door sensor. That one's pretty cool. That one you could probably use some Bluetooth with. Maybe it interacts with a light nearby. You don't really need the internet, but that kind of wireless communication could trigger other devices nearby. That would make it pretty useful. And then you get down to the bottom, you talk about some Pimoroni stuff. It's pretty cool. Things to get excited about. So yeah, the Pico W, it's been around for a while. We've been itching for some Bluetooth. I'm really excited to see what the community puts together once we do have more comprehensive, easy to use Bluetooth code to play with. But until then, get inspired by those maybe and send us what you make.
Very true. But talking about drones and Bluetooth, it's
Yeah.
been on my shelf for a while. You may have spotted it in a shot. This is a Parrot drone. Which one it is, I can't remember now, but it was £25 from Amazon. And I got it because we were using it with some kids about 5 years ago in Manchester to teach them how to program in Swift, the Apple language for coding. And you could program this in Swift, but then I found out you could program it in Python. And it's got Bluetooth. So I set about trying to find a library, an abstraction library to work with it. And I found one. So I could program 2 drones over Bluetooth to fly around my living room and not crash into each other.
Neat.
25 quid. I mean, it's got like a flight time of 5 minutes, but great fun. It teaches, programming, but also interactively and how not to crash. You can measure distances. It's got a camera to take photographs. I was very impressed with it.
Yeah.
Well, yeah. That just reminded me then seeing that drone on the projects.
The battery life is the only thing holding it back.
Yeah, very much so. But talking of drones, robots, and all these wonderful things, I'm going to go to the overhead shot now so you can see this. Now, this looks like it's going to take over the world, this thing, I think. So,
Look out, Boston Dynamics.
Oh, yes.
Yeah, but this has got a cute face. It's got to be cute.
It's got 2 lovely eyes and a grabbing hand at the front that's going to maul us to death. It's not really. I'm joking. Electric Freak sent this for review. It's a CM4 XGO robot kit. Now, it comes in a wonderful flight case. I haven't got banana for scale, excuse me. But I'll just open it up so you can look inside. Comes ready built. It's got a Compute Module 4 inside of it. But hang on, no, you're saying this, you're saying it's cool now. Just watch for a second. I haven't done any programming on this whatsoever.
I think it's cool that it just comes pre-assembled. I thought you'd have to build it.
Ditto. I had the screwdrivers ready. So it hasn't got a name yet, but I'm going to have to name it sometime because obviously it is a robot dog. I'm going to press the power button. Now watch. The dude gets up, walks around, and the screen is just powering up now. Yes. He also traps my fingers occasionally when I put my hand in a bit too quick.
That's extremely sick.
You've got a CM4 inside there and a camera. So this has got gesture recognition, machine learning. It can detect colors, objects, track people, which is a scary prospect. Right. It's got some metal pincers up here to pick up balls or objects. And you can program it in Python, but it's also got a block-based language. So if you want to play around with kids in a classroom with this, you can.
Is that a little touch screen on the front?
Not a touch screen. No, you've got 4 buttons.
Okay.
Let's get it in shot, Les. You've been doing this for 134 episodes. You shouldn't be doing. So you've got buttons on the side here and buttons on the side there. And you can just select what you want it to do. But I need to do a proper full review on this, not just, hey, look, it walks around the room tracking things. I need to program it. But it's awesome so far. It's aluminium. It's not plastic. It's all aluminium, and it's got decent servos on it as well. It's
How
not
much
just
does it weigh?
5 bananas.
5 bananas, okay.
5 bananas. I've not got the scales to weigh it, so I don't know what it's about. 5 bananas in weight.
Crux here is it's not only totally programmable as it is, but because it's based on pretty standard hardware, you could throw away all of the software on it and write your own from scratch if you were so inclined.
Exactly. So
which makes you want to, since it comes already set up, makes you wonder what it's running.
But in a classroom, if you had it with Python or the block language, fantastic. You've got fun all day for the kids. They'll eat this up. For the makers like ourselves, we want to do our own thing and build something out of it, and we can. But here's the crux we've got. The price. $749 for the robot. That's a lot of money to drop on a robot, so you've got to be serious into your robots.
Kevin,
yeah, I'm thinking Chris as well. Kevin's already got one of these, I know, so I've seen his video.
I'm sure he does. That's awesome.
It's probably going to the shops for him every day to pick up some shopping, like a pint of milk, and bring it back for him. But I'm going to do a full review on this and get to grips with how it programs, how it works, and understand what you can do with it. Because it's a lot of money, but it's also a lot of kit. So you need to get as much value as you can out of it. So I'm going to have some fun.
Does it have any kind of like... Oh, go ahead.
I was going to say, have you seen the Optimus Prime robot?
Yes, and I want that.
I tested the... it's basically a fully articulated robotic Optimus Prime that's voice controlled. Wow. So you say stuff like Optimus Prime, stand up, and it transforms from a lorry in front of your eyes and stands up. It's completely ridiculous and just unashamedly exuberant. But
they released this second one with the trailer as well.
It's just absurd, cool. But it's glorious. I tested the kind of less flashy version of that, which I was really hoping would be something like what you've got there, Les, something that's actually programmable and you can really delve deep into the automation control and stuff. But instead, it just comes with an app that you have to create an account for to sign into, and then you have to wrestle with the app to get it, and then you've got this little tiny thing on your phone to program it through, and it's not fun.
That's where, yes, it's a lot of money, but that's where it differs in that you've got full control over it, so you can have it do whatever you want. So, the pincers, you could have it. I don't think it can carry a can of Coke. That'd be great if it could, or a beer. It'd be lovely. But you can program this to do whatever you want. So, walking around the room, following people. It's got machine learning because you've got, Raspberry Pi 4 in there pretty much. So you've got
Does it have a speaker or anything for audio output?
Most likely it does, yes.
Is that you can have fun with that?
Have some dog barking noises when it walks up behind someone.
Yeah.
Bring back the iBo.
I mean, we were also testing one called the Biddle X, and we tested the original Biddle, and those are made out of plastic and cost half, or still expensive, but cost half as much. And we definitely found that, at least on the original Biddle, it was kind of a challenge to keep them together. Yeah. And if you showed them to kids, like the kids could be picked out because the head would keep falling off, like no problem. So that, I mean, you pay for metal, you pay for good quality materials, right?
That does make a difference.
Both in money and pinched fingers.
Yes.
Yeah, twice it's pinched me today so far. But you're also paying for good servos. You can build a robot with hobby servos like the Tower SG90s, but you'll constantly see like the little jitter that they have every so often. Is it PWM? Chris is going to correct me on this. I know he is. He'll watch this. You just have a little jitter every so often. But with this one, I've seen no jitter whatsoever. I mean, I've played with it for about half an hour. That's it. But in that time with a standard SG90 servo, it would jitter. Especially
with servos, that'll make the price go up really quick if you have enough.
Yep. Are these the weird serial servos I keep hearing about?
They're the better ones, aren't they? The SG90s are just PWM.
Yeah, they are just PWM. You have to get this narrow little, I think it's like a small window within a 20 millisecond window or something like that. I can't remember. I haven't programmed servers for ages, but it's decidedly unfun.
They are.
Kevin's answering questions. Yeah, servos are serial.
Yeah.
And he says it does have a loudspeaker.
There you go. You can tell when you play with it for half an hour. Kev did a whole video on it. I had half an hour.
Yeah. Well, thank you so much to Phil for joining us on such short notice and sharing with us the exciting things that are going on at Pimoroni. I was hoping I could share the latest progress on my game, but somehow I've managed to mess it up. So now it's no longer displaying the pixels. I'll figure that one out later. But we will. Are we going to be on next week, Les, or are we taking a week off for July 4th?
I shall have a look and see if I can find an interesting guest, and if we do, we'll be on.
So since I think Les may be here next week to do it. So hope so. Anyway, we will see you guys, everyone, again soon. As always, we're on Tuesdays at 7 p.m. UK time, 2 p.m. US Eastern, and we'll see you soon. Bye, everyone.